Recording has started.
Okay. So, hello everyone. Good evening. Thank you for being here today. It's great to see many talented individuals gathered here. As many of you already are aware, Composable Solutions brings incredible opportunities. We are talking about building the systems which are flexible, scalable, and adaptable to change. And the potential scope and learnings are huge and amazing. Let's be honest here, integrating all those different modules. Yes, I can read your mind voices. Yes, that's true. Where the real challenges are lies in. That's exactly what we are going to explore today. So let's dive into the today's topic, tackling integration challenges in composable architecture. Myself, Sathyamoorthy, but you can call me Satya, working as a lead software engineer at AssureX. Today, I'll walk through some common pitfalls, best practices, and some real-world examples. I hope at the end of this session, you will have the insights to unlock the power of modular solutions. Once again, thank you all for being here, and let's get started. Before we dive into today's topic, I want to share a quick quote perfectly captures the spirit through this journey. Think about the challenges we had faced in our paths. Each one is an opportunity for learning and growth. So in this moment, I would like to thank my mentors, colleagues, and of course, my community friends who are all played a key role in guiding me on this journey. Thanks, everyone. All right. So as usual, I would like to give you a brief outline what I'm going to cover for today's session. We will be discussing composable architecture and common integration challenges, especially transitioning from monolith to composable solutions. And some of the case studies and experiences from my assignments and key takeaways at the end as a summary. And finally, brainstorm break. There is a reason I named it as brainstorm break because I always believe in crowdsourcing, where I used to get and learn something new from all of you today. So let's start composable journey. So the picture displayed here, it's not something new, and definitely it is not kind of like a new to, or like it is more familiar to most of us already. In fact, I'm sure we all encountered at least one of this product during our journey. Now, while this picture may look sleek and appealing at first glance, what really matters is what's happening behind the scenes, or like what's happening behind the systems. Integration is the unsung hero as always, because everyone is kind of like looking at the front end and nobody cares about kind of like a back end. It is unsung hero as always. So without seamless integration, even the most polished system can collapse under the pressure. But today I'm not going to uh, dive in more into this kind of like Sitecore offerings. Instead, I'm going to kind of like explain the kind of like integration part behind the scene. So let's just flip this picture. In a composable architecture, on the left-hand side, I've listed the elements which cannot be inevitable. Without this, composable architecture is not possible. And the characteristics that would define, okay, the solution is a composable architecture. So let's start with few elements. Composable architecture is built on the principle of modularity. Each component operates independently. It contributes to the overall the system. Interoperability. So that is truly empowers the composable system. Each module with the architecture can communicate seamlessly with others, regardless of the technology or platform. The next step is like scalability is one of the biggest advantages of composable system. So we don't need to overhaul the entire solution to meet the growing demands. If there is an issue with the order system, only we can focus on ordering services or ordering related services to scale them up. That will solve the issue. So reusability. When there is a solution already in place, why we need to kind of like recreate them and why we need to reinvent them? So it is already proven and it is working perfectly fine. We can just integrate it with our composable solution, start using them today or like whenever kind of like we wanted it. Just we need to make sure whether that composable component is really adding and value to us. Then resilience. This is kind of like one important stuff in the resilience, like failure of one of the components or like one of the system it shouldn't affect another and shouldn't create adjacent effect on subsequent kind of like a systems. So because of this character, we can kind of like believe in high availability and minimizing the downtimes. So on the left hand side, we have elements. So that part, I'm not going to start it off now. We will be looking into in the upcoming slides. I'll go to the next one. So microservices and micro front-end services. So microservices, like specialized teams in an organization, each team has a unique expertise. One will be taking care of processing the payment, and another one will be taking care of authentication, registered user flow, or some other stuffs and all. This separation enhances the efficiency and adaptability of the teams to avoid the bottlenecks of the traditional architecture problems, whichever we were encountering it in the conventional systems. Let's go to the micro front-end solution. So this idea, actually, the larger UI portions broke down into the smaller user interfaces, and these are all independent pieces. It doesn't matter whether one app is built on React and another one is on Angular, another one is on Vue. So at the end of the day, they can seamlessly work together to provide the best experience. All right, I'll go to the next one. Yeah. So the main and major element within the composable architecture is the business function parts. We can say composable components too. So the main idea is simple. We broke down large systems into smaller parts. So here, the system which I meant is one MVP kind of stuff. So it has the definition of clear purpose. Let's say CDP. Okay, that's the purpose of CDP is to kind of like maintain the customer data platforms, customer data information. If it is like a dam, we used to keep our digital assets in them. So something like that, we can say like it is an independent composable component. There are some characteristics which defines our composable components. So first one is modular unit. So when I say modular unit, it is teleportable, and it is like a handy, and it should be kind of like integrated with other solutions, which means adding the building blocks, or we can even consider Lego toys. The next thing is like autonomous. The term autonomous, though we have slight dependencies with other systems in terms of what we get it and what has to give it as an work done. Other than that, it shouldn't be having any dependencies with other systems. Compatibility. So this one also kind of like ensuring compatibility of this composable component, ensuring it is working well with other components, other composable components. Then fourth one, it must be API driven. The communication to this component or from this component, it always through API. So without kind of like accessible through the API, then there is no point of kind of like calling them as a composable components. So the outcome focused. Finally, just a moment, I'll quickly minimize this. Yeah, outcome focused. So each component is built with a clear purpose, whether it is personalization or CDP, or it is kind of like a DAM system, or like it is connectors for any of the third-party systems. So it should be having the clear purpose. By focusing on outcomes, we can ensure everything works towards the meaningful goal. So these are the characteristics defines composable components. Let's go to the next slide. The next element is service mesh. So the service mesh is something kind of like even it's a tongue twister word to me. I couldn't pronounce it properly. The layer that manages the communication between microservices and distributed application. So there is a kind of like a purpose of using service mesh instead of directly using serverless functions or like a web services or something, because it can address the challenges like traffic management, security. It has its own observability resilience. It has two modules, data plane and control plane, whereas control plane will be taking care of all the policy managements, configurations, stuffs. But data plane will be taking care of traffic between the services. So when do we need this service mesh? One is like when we have a large scale microservices architecture, it is ideal to use it. Whereas when we don't have, or like when we have a small scale microservices, or like it is just a minion kind of stuff, then we don't need service mesh. And there are popular service meshes, like I can say Istio, Linker, the one which I've displayed here is Nginx. I'll in the upcoming slide, I'll like I'm gonna take through like where we will be using service mesh and its application of service meshes. Okay, so this is kind of like a very interesting part of mine. In a composable architecture, so these are the areas where I can see we will be having most of the kind of like complexities and the challenges. Authentication and data synchronization part, change management, especially when we are working closely with the cross-functional teams, change management is always kind of like operational silos. So that we will be looking in detail in the upcoming slides. Traceability and observability. Since the scale of the solution is extensive, it is very complex to identify the process as well as identify the health and the vitals of the systems. So that we will be looking in them in deeper. Then the case studies like headless for the commerce integrations. And we have popular commerce ERP tools, which is outside of Sitecore, which is like a Dynamics 365 systems, Magento. Even we have few more systems like e-commerce. But here an example, I've taken D365 and Magento. All right, so let's go to the next slide. Identity assurance and access governance. That is the reason I kept the title as identity assurance and access governance. The reason here is like composable architecture becoming the trending standard in application development nowadays. By deconstructing the systems into independent interchangeable services, we are going to unlock the flexibility, scalability, and accelerated development cycles. As Peter's uncle Ben wisely stated, the great power comes with greater responsibility. So same like as modularity provides numerous benefits, here also it brings increased responsibilities to address the challenges. As we have multiple services interacting through public endpoints, securing them, it is very essential and complex task. Moreover, the stateless nature of the microservices demands that each request must carry all the necessary information about the session, about the person, about the, let's say like we usually exchange the tokens. So it requires kind of like a claims related information over the token itself. This is kind of like makes the configurations more crucial and integrations more crucial because we cannot expose the tokens directly to the kind of like a browsers. Somehow we need to keep them in Redis or any of the kind of like state management devices. Then we need to use them with some kind of like encoded data, and that key we can keep it in the browsers. And excuse me. So this is especially challenging when the customer can only interact with the systems through user interface. And in the next slide, I'm going to explain that part. So we will be looking at the distributed services part. So what we can propose, or like what we can how we can overcome this kind of issue is like we can go with OAuth or OpenID Connect for the federated identity and SSO such services. Second thing is like a stateless natures. When I mentioned before, like a stateless nature, it is complex to kind of like integrate microservices, especially when the session carrying processes are like a request. So OAuth and OpenID Connectivity, they were providing kind of like JWT token. We can always embed personal information like a name or kind of like an employee ID or like a claims related information as part of the JWT token itself. So that will ensure the session will be carried forward through the token. Moreover, we are not exposing microservices endpoints to the browsers. Browser will always connect with backend for the front end layer, like BFF layer only. So that part, like I have another one slide, I'll be explaining that part. Then granular access control part. So here, in order to overcome the issues, either we can go with role-based access control or attribute-based access control. That is part of our OpenID Connect anyway. So we will be having more options to configure kind of like our authorization mechanisms. Then in addition with that, for example, if it's a registered user flow, We can always enforce the customer to opt in for multi-factor authentications. Also, we can enforce zero trust architecture, which means like any request which comes to the microservices will be treated as an public request. It is not something kind of like a genuine request or authentication. Every request we are suspecting it is kind of like a unauthorized request. So when we add more checks in it, then when we add more filters in it, then we are safe and we can kind of like those kind of enforcements makes our life easier. Right. So I'll go to the next slide. Yeah, this was the slide I was talking about. So here, if you see, like, first I'll give the background on this picture. So where you can see front-end solution in the left side corner, and BFF layer is the, I mean, it acts as the backend layer of our front-end system, where I've kept Redis, which is not accessible to the front-end layer as well as users. Only BFF layer will be having an access. So the flow, if you see here, users, when they try to access the solution, and the solution doesn't have the browser cache about the session of this user. Instead of kind of like bring the page, it will be redirected back to contest page or like a challenge form challenges pages where the user, they can provide credentials to authenticate themselves. It can be multi-factor authentication or like it can be forms based or anything like that. It depends on their configuration. Once the challenge is done, then the redirect URL will be sent back to the BFF layer. BFF layer will be sending a reroute or like a reroute request back to front-end layer. And the BFF layer also will be responsible to write the transformed session key in the front-end layer cookies so that whenever the user next time, when they log in into the solution, they don't have to go to the forms or like a login flow again. Since it is having that session information, BFF will be using it. And BFF also will be taking care of storing the token in the Redis in the encrypted format. So when the next request goes to the microservices to access any of the resources, it can be DAM, it can be like any commerce solution or like any of the resources servers, the request will be tailored with that session tokens. So this is case one. I'll go to the next one. The next challenge is data synchronization and consistency. When we have a large number of services working on the common goal, let's say multiple microservices, front-end systems, the entire solution, the common goal is to provide the unified experience back to the customer. But often we used to end up with the data conflict, especially when the multiple services passing the same data. And sometimes in the resilience, the data may not be compatible or data may not be kind of like relevant because people, they were using scaled environments. If they are using kind of like sticky sessions and due to some issues, they may not revisit the same server, same instances. But that is something kind of like quite handled in the application gateway side. But fragmented data sources is something like within the solution when we have multiple sources. So how are we going to kind of like resolve the data? And next thing is like real-time data updates. Probably I'll go to the next slide. I'll be explaining them with some use cases here. Yeah. Background of this diagram, the main intention to explain this here, just an example. Let's say front-end solution, user from the front-end solution, they were trying to place an order through order service, and the order endpoint sits in commerce, and we have to use it through gateway. So it is not something we can directly make a call to the commerce because we don't know the availability of commerce. We need to have a kind of like event-driven architecture here to ensure the order placement is properly, even if it is delayed. It is kind of like handled after 30 minutes or an hour or whenever the services is available. But that is not alone going to solve the problem. There is another one thing. In the order service, as soon as, because user, when they add the product into the their cart, probably only kind of like one of the product is available or like one quantity of the product is available and that order is placed. But that product inavailability or stock informations will be sent back to the next day solution. So usually to have this information in tip, we will be having it in the indexing solutions. In my use case scenario, I kept an example like we have the inventory details available in such tags. As soon as order is placed, we will be receiving the feedback through order service only. Order service will be updating the index inventory like 0 now. So here, if you see, there are two actions and responsibilities of this order service. One is to place an order, another one is to update the inventory. So to avoid this kind of like multiple flows, right, we can employ Kafka brokerage system. So what it does, whenever the order service kind of like sending an information, I'm going to place an order, then Kafka will be having subscribers. We can consider two subscribers. One is for to place an order request to commerce. Another one is to update the inventory back to such tags. I understand. Here we won't be validating whether orders placed and that event is succeeded or not, but eventually we will be sending it back to both of them. The main intention to explain this data to event stuff is to explain event-driven architecture into our solution. So the Kafka, we could have easily leveraged bus services or queuing services. But the main purpose of using Kafka is to maintain the streaming, data streaming stuff, that too in the real time. I'll go to the next slide. So yeah, I'll quickly finish this one. In the producer, as soon as Kafka receives the update, it will send an event back to subscriber 1, which is Dynamics. Then next request subscriber 2 back to such tags. In the next slide, just consider like this is one of the order service, one simple use case. Let's take an example of the entire picture of the e-commerce solution, right from generating the catalog informations and having them displayed in the product listing page, and letting the users to place an order, payment, and then fulfillment after the post-purchasing events. And once that is done, then review that workflows. In this entire life cycle, there were so many events being occurred here, but having them, having said that micro services, it is like a large in scale and more in numbers. It is not always kind of like a adding the logs or adding the informations in a kind of like centralized place. Often we need to use distributed logging stuff. So how do we kind of like merge them into as an events here? So what we can do, like in a Kafka, we can ingest this information, and from Kafka, that information will be ingested to Azure Data Lake. So there is a cluster available. I mean, there's a system Apache Spark. What it does, the purpose of this Spark cluster is to process the data. It will do, we would have heard DQS, data quality services, and data refinement services. So this will make sure based on the kind of like a business rules, this will refine the data. It will again ingest the data back to Kafka. Again, the data will be sent back to Azure Data Lakes. So this way, the information and the event details will be logged in Azure Data Lake, which will be configured through Power BIs as a custom insights. Whereas, for example, like business users, they can easily identify the stock informations, how many orders being placed, and is there any issues or hiccups during this cycle. So this is where data synchronization takes place, and this is something kind of like quite important to make in our composable architecture. And there is a link I've provided here. Sorry, I'll go to that slide, then I'll bring it back here. The next challenge is change management, because having the large number of solutions, large number of teams, having everyone in the same page, it is too difficult. And moreover, if someone is working on the transition from monolith to composable architecture, because it is something like everyone will be having hesitations, like how do we work together with cross-functional teams. There could be a kind of like operational silos, like what I need to provide, what would be my definition of done, what would be like a cross-functional team's definition of done. So like in the starting time, there'll be kind of like a learning curve. And during the time, we will be having kind of like a resistance from the resources side, like how to proceed further with the kind of like implementations and all. So to overlap these kind of things, what we can do, provide the separate trainings, and we can arrange a kind of like a design patterns, and we can take case studies. Also, definitely there could be a kind of like people will be taking the lead to kind of like identify the options, solutions. Probably we can kind of like advocate, we can make them kind of like a change champions, and they can kind of like train junior pupils, and then we can propose more options. The next thing is like a governance and oversight. When we have a kind of like a large number of systems and the solutions, governance is a big issue, because in every composable component side, every integration side, we need to make sure testing is done and automated test cases takes place, because everything kind of like even if we update any minor number of minor code changes, then that needs to be kind of like taken care to see like whether it isn't creating any impact on other sites. Then interdependencies between modules. So the same thing, like as services become modular, the complexities of managing interdependencies also kind of like quite complex. Changes in one module can impact others. That is inevitable anyway. So to avoid this one, we can always kind of like decouple the services much as possible. And moreover, we always prefer to go with a kind of like a API first approach to define the contracts. Then we'll work on the implementation part. And moreover, we can add automated testing to make sure the dependencies are properly tied up even after the changes. Then communication and coordination. So though we have an option to kind of like deploy our solutions independently, we need to have a kind of like coordination across the entire solutions to make sure everyone is on the same page to know, okay, there is a deployment is happening on the solutions, so that we can make sure nothing is breaks on other part. Having said that, we have all the automated test suites available. Parallelly, there are some edge cases which cannot, because the purpose of having microservices architecture and composable solution, the main intention to have them to go for the faster deliveries. And when we wanted to kind of like coordinate all this stuff, we also, as a human intervention, also might need it during that journey. There are a few more, like I can point it out, automated deployment pipelines. So we need to maintain deployment workflows, CI/CD stuff, rollback and recovery also kind of like a major. And I have versioning slide as well. Okay, that's ideally supposed to be next to the version. Yeah, ideally supposed to be the next to the change management, versioning and impact matrix. So in order to identify the changes across the system, we need to provide clear and proper versioning into the solutions. Let's say semantic, usually we can go with a major, minor, and patch. Usually in the major part, when everyone is needs to be intimated and involved on the integrations, we can go with the major patch. If it is kind of like a smaller minor patch, we can go with kind of like a versions like something like a 00.00.00. The last one will be like patch. The next one is like API versioning. So for this one, it's like entire system. But for the API versioning, usually we'll be having changes on 3 different places. One is on API URLs, header versionings, and the parameter versionings. On the URL versionings, we always go with the kind of like version 1, version 2 within the URL itself to make sure everyone is kind of like aligned with that part. And header versionings, we need to have it as a minor new features, and that needs to be informed with other dependent systems. And backward compatibility. The reason like why we need to have a backward compatibility, because when the clients to upgrade gradually without breaking their existing functionality, this backward compatibility must be in place. This ensures system integrity even after the challenges. Okay, the next is like a future toggles. So whenever we introduce any new feature into the solution, it's also nice to have an toggle or switch to enable and disable. This allows us to kind of like easily handle the new features. Also, if there are any unforeseen situations, we can disable them without affecting subsequent components or like subsequent processes. Next thing is like a documentation, which is very essential. So even documentation also, we need to make sure it is automated. Let's say like if it is an APIs, then we would go with Swagger's kind of where API information is to be captured and agreed from the other parties. Automated testing I covered as part of the previous slide. So deprecation policies. So let's say for the because whatever the solutions we are bringing in place, we don't know how long that solution will be available because we keep getting the new requirements and contracts may change. So whenever we deploy or whenever we introduce any new API or new contracts, we need to make sure deprecation policy is also attached in that. So that reminders also should be in place on the documentation part. This will make sure everyone is informed on the solution side to make sure like a future uh, required action can be planned on their schedule. Next slide. So as part of the challenges, like what I would think like let's start it as a Mac because we were there in the era of monolith and we were trying to move them into headless architecture. So we'll start it as a Mac that would allow us to kind of like handle a couple of challenges in the early stage itself. So one is like microservices part. So the complexity in managing them and deploying them, that is kind of like quite challengeful. So what we can do here is like use a service mesh or like use a container orchestration, like a service mesh that would solve most of the issues like traffic management and security and scaling and even like observability related steps. And next thing is like data consistency across microservices. To employ event-driven architectures within the microservices, we can make sure data is consistent across the processes, I mean, in the systems. Next is like performance overhead in headless setup. So to optimize kind of like endpoint counter, what we can do, we can employ CDN or like a static assets. For example, every time to fetch data from the kind of like a GraphQL endpoints or web services endpoints, if we know that data is static or not to be updated often, we can have them as a static asset as a JSON data in the CDN itself. So that will be useful for us to avoid redundant calls back to the endpoint. Next thing is like API versioning. So managing the multiple versions of APIs, it's too difficult. And we need to categorize them using APIM in Azure. We can kind of like always have the segregation of APIs that would allow us to focus on APIs specific purposes and documentations. Right, let's go to the next one. The integrations part. So actually, I'm going to start that integration part from this slide. From the conventional systems or like from the olden days, there were three options for us to integrate external systems or like integrate cross-functional systems into our solution. ETL, definitely no need an intro on this one. This was conventional and being employed in multiple places. But the main problem here is like it requires kind of like a data warehouse complexities. It has its own complexities, and moreover, it is not kind of like a real time. Whereas ESBs, enterprise bus services, but this is kind of like a messaging queues. And here also, complexity is more because where the integrations, we need to kind of like define the contracts between the microservices. The definition of done to be clearly defined on the systems which is interacting together. Whereas in iPaaS, the main idea of iPaaS is to have it in the cloud native. That is first thing. Second thing is like leverage the SaaS features. And moreover, iPaaS, it's more like a globalized one and commercialized. We can easily find the connectors. We can easily kind of like identify iPaaS services from the external system, but it is not kind of like comfortable. We cannot assure it is completely fulfill our needs, but there is an option. We will be having an option to accommodate the customization in iPaaS. Whereas ESB, something like needs to be started and needs to be created from the scratch that will allow us to build it based on our needs. So in the iPaaS, it is best for kind of like a real-time integrations, especially SaaS and on-premises systems. Whereas ESB, it is not. In iPaaS, it is low code, whereas like no code. But in ESB, we will be having kind of like a customization as well as orchestrations, which requires additional complexities, which requires additional kind of like efforts from the infrastructure side, as well as it requires kind of like orchestration from operational side. I go to the next one. Yeah, this is a kind of like a side-by-side comparison of integration approaches. If we go with iPaaS, it is highly scalable. In EBS, while comparing iPaaS, it is not scalable much, but in the ETL, it is kind of like offline processing, like through data stuff. So it is not real time in EB. And there's another one comparison. I missed that one. There's one more comparison. Sorry, I printed one. And in terms of maintenance perspective, we were employing most of the SaaS features. So mostly the responsibilities will be less on the iPaaS side, whereas in EBS side, it will be kind of like a more. And ETL side also, it will be kind of like a similar, and we need to kind of like, we need to have a resource to kind of look after that one. Transformation capabilities. So here it is more like a kind of like our customization, our needs. So here it is moderate because it is globalized and commercialized, and people always try to provide generic and standard support to enable kind of like integrations. Whereas in EBS, it is specifically for our own need. So it is having an option to kind of like provide the compatibility. Slide. So it's a typical solution where we were kind of like using iPaaS, even in our Sitecore Connect kind of like worked on top of Worker 2, where we can see many connectors available to integrate our Sitecore solution with third-party systems like Dynamics or Magento. It's a typical solution. Yeah. So the main intention of this diagram to provide the integration on our Sitecore solution that to kind of like an headless platform to the dynamic system, Magento and InfoRLN. I'm not sure InfoRLN kind of like a famous across the team, but I can provide a kind of like intro on this. Like it is an ERP tool where catalog and product informations tailored based on the personalized information from the users, and the system will be very much helpful. So here, in order to kind of like access the data, let's say I need to, let's take an example. I wanted to display the customized and product information. The product details are from Dynamics, and that information will be streamed back to my PLP page. So there is an option, endpoint is available. We can directly make an API call to get the data, but that is something kind of like real time. Every time we cannot make an API call. So to avoid this one, directly we can ingest product information back to the XM cloud. So let's see how we can do that part. So one is like we can ingest product information back to the Kafka's producer endpoint. So in the Kafka, in the other side, subscriber endpoint given to the catalog service. So the product informations will be ingested to Kafka, and the catalog service will be fetching that information. Once the information is fetched, that will be added into the service bus. It is a sync queue, and from the sync queue, we have storefront sync service that will fetch the product information that will pass it back to the authoring API services, where we can create product information into the CMS tree. This is one use case. And another one is like, let's say I have kind of like a product information, but I don't want those information to be indexed, and I want specialized index collections as part of such stacks or Solar or LucidWorks. I wanted to have a kind of dedicated index for that one. So let's have the product information indexed in a separate kind of like a such stack solution. So Same, whatever the storefront information, product details, and the inventory details, product details plus inventory details, we can sync it in the queue. And we can have another one microservice. I mean, I can say like a service mesh service, which will fetch this information and it will index it in the search tags. So this information will be used by our Next.js solution to display product listing page. So this is just for the kind of like a catalog service solution. Let's say I wanted to kind of like go with the checkout services. So the real-time handling checkout cart functionalities, that thing and all kind of like quite complex. And often we will be making an API call directly to the e-commerce solutions. When the large number of loads hits, we don't know kind of like the system, how it survives. When it is like SaaS and scalable, it's not an issue. But when it is like a solution like Magento, we need to kind of like make sure that e-commerce solution plus a backend ERP solution is decoupled through the event-driven architecture. So let's say one of the users trying to place an order through Next.js solution. The checkout service will send that order-related information back to the authorization queue. Meantime, I can place an API call back to Magento. I can create the sales code, but that sales code is not turned as an order information. We can keep them in the queue. From the queue, in the queue. Parallelly, we can expose another one Kafka subscriber endpoint and producer endpoint, where we can ingest this queued information back to the Kafka producer. And this information will be sent back to ERP system. So this way, we can make sure order placement flow is decoupled between e-commerce solution as well as third-party integrations. Yeah, I'll go to the next slide. Yeah, transitioning from transitioning into composable from monolith. So here, we can consider it's a kind of like a tips, or these are all kind of like areas we had encountered hurdles, or like we had faced the hindrances. So one is like first thing, whether it is bottleneck, performance bottleneck, or whether it is in kind of like limitation of our monolith, we need to identify the pain paths. We need to pinpoint those painful areas. Then second thing is like we need to separate the goal. We cannot boil the entire ocean in a single day. We need to take the small scoop and we need to kind of like boil them. So, and we need to make sure that goals and kind of like a definition of done is proper in that one. Then whenever kind of like we isolate or decouple any system, we need to make sure that should be reused in other places as well. For example, if you are taking, we will be decoupling the services for the cart, then that services we can employ for, let's say like other purposes to take care of event syncing, or like to take care of centralized logging information to pass the data back to Kafka or something. Okay. Then rinse and repeat. So first thing is like, we'll try to kind of like make an API call. Let's see the data, whether it is properly communicating each other between the services. Then we'll revisit that area, we'll refine the approach, we'll simplify the thing. It's something like people used to say, KISS, keep it simple and clean, something, don't recall that part. And the second thing is like, first thing, we need to make sure the communication is happening between the services. And next thing, since it's a decoupled solutions and microservices, we need to make sure it is monitored and it is kind of like someone kind of like governing that part to make sure there are no abnormalities or no issues in that part, because observability and traceability is important on these areas. Then as soon as that services were employed and it is done, and we don't have to remove the monolith architecture until we have the confidence on microservices part. Once everything is fine, then we can slowly retire monolith solution. And same, like we can keep getting the feedback and we can fine tune our solution. Summary. Addressing this kind of like whatever we had seen so far, like these are all common challenges and some of the kind of like integration approaches, and a few of them still it is under kind of like a research to make sure like in any another way, I mean, any other way where we can simplify the data transactional steps between the solutions. And the other thing is like whenever we employ any new systems, it is okay to kind of like decide, okay, let's employ the solutions. But when we integrate all of them together, operation and data silos are kind of like inevitable. And we need to make sure the orchestration is happening smoothly on operation as well as data silos. And starting points. So we need to kind of like first pitch in to see like from where to start, and traceability. So this is kind of like important, and this is something like a backbone of the systems to identify what's happening behind the scene. And next thing is like composable architecture, right, for us, because uh, even for it depends on the kind of like requirements. Whereas when we have a larger uh, an e-commerce solution, they were having kind of like a one zone. They were trying to do store operations, POS things. In other place, they were trying to kind of like do the business in the physical stores. In other place, they were doing e-commerce solutions. All these places, we need to maintain the information, and we need to kind of like have the real-time informations to be flown through all these solutions. Then that time, in the large-scale applications, composable architecture, it is good. And moreover, that is kind of like having value also. For the smaller number of smaller scale solutions, composable architecture, maybe we can go with the SaaS offerings. We can start using them to avoid kind of like cost as well as kind of like additional efforts. Yeah, I think I was so rushing on this part. It came to the kind of like a brainstorm break. I can see many kind of like comments in the chat. I didn't get a chance to kind of like go through them because I was rushing through these slides. I'll sure definitely kind of like going through the questions and I'll answer them. But meantime, like the room is open for questions from the team.
Hey, Satyam. Sure. What I'll do is I'll just try to narrate the questions from the chat to you. There are
Sure,
a
sure,
couple of, I think everyone was very fascinated with the presentation. So there are a couple of questions.
sure,
Respecting the
sure,
time, I'll try to take a few questions now.
sure.
Let's see. So I'll start with the first one. What's the difference between content operations and content hub operations?
Okay, so content hub operations. Uh, I can give an kind of like an example on this part. In the content hub operations, like uh, traditional, let's kind of like keep it away that traditional content traditional content system in our content tree. Let's take a content hub example, like where we have a kind of like a content system which is kind of like audited, and where we need to kind of like employ them and govern them in that content hub solutions. We can employ kind of like third-party systems or kind of like a microservices. Let's say I wanted to kind of like have an auditing. One of the solution, like we wanted to maintain the governance on the data which is being displayed in the website solution. We can have the microservices to audit kind of like a content hub data. So that is something from my perspective, it is like content hub operations. We can proceed it. And the content operation, there are some places like we need to ingest the data. We need to get it from different types of feeds, and we need to collate them, and we need to create it as a kind of like a source, and that needs to be available for another or subsequent systems to continue with. So that is something like a content operation where we will be transforming them for our business needs. Not sure like whether my example or like my use case is suitable. Probably like if you can get the kind of like a more precise in that question, right? I'll try to get an answer to this.
Sure, sure. No worries. The
Yeah.
next question is you have already answered, but I'll just ask it. What is the
Mhm.
use of iPass layer?
Yeah, good question. So let's say in Sitecore offerings, one of the offerings like we have Sitecore Connect, right? That we all know, like it is been built on top of Worker 2. Let me quickly go back to my slide. in my solution, in order to integrate dynamic systems into our headless solutions, I had used my own microservices. I was ingesting product information back to my Sitecore solution using our own microservices. But if you use Sitecore Connect and iPaaS, it's a kind of like a platform as a service providers like Workato. They can provide ready-made solution. It is like there you need to define your recipes, like uh, how the data to be kind of like a fetched in, what is the trigger point. So it is entire solution as a service. They can provide it to us, which means there were no code. It is just graphical user interface, allowing us to kind of like a define how the data to be processed and to be ingested into the solution. So that is the iPaaS layer. It is quite commercialized now, and we can see outside there were 400 plus connectors which is ready-madely available. Even for Magento itself, there were 4 to 5 connectors available from different vendors. So hope my question is, question is answered.
Sorry, I was not able to unmute myself. But yeah,
Oh, sorry, it's okay.
so do you want to continue with the session, or like we can take the questions at the end of the session?
Sure, I have few more. It's okay, we can continue with this questions part. That's where the slide I was intended to bring it in here in the slide.
Okay, sure. Like since you took it like a small break in between, I was thinking like that was the end of your session, right? So we can continue with the questions.
Yes, please.
Okay. So the next question is, web services are outdated that we used in ASP.NET and web forms, or it is something different? And the next connected question is, even SOA, right, service-oriented architecture, we used in past with Java technology. People don't use SOA architecture now. How will you use SOA here?
Okay, so I can understand like there were the times like people were using service-oriented architectures, but here, right, the services like Kubernetes, when it is employed, we don't kind of like need a service-oriented architecture. As I mentioned before, when a large-scale system requires kind of like architecture, then we can employ service meshes and all. When the smaller scale solutions, those kind of like a requirement, we can easily use like service-oriented architectures. We can easily employ Azure functions or AWS Lambdas to kind of like fulfill our needs. So absolutely, it was not a kind of like a issue or something. We can go with that part as long as like I could remember in one of my assignments where we need to migrate kind of like a Sitecore retail connector into Dynamics Sitecore retail connectors into dynamic proxy APIs. So we removed retail connector functionalities from Sitecore solution. We were using Azure functions to make an COT functionalities and make an kind of like a checkout steps and all through proxy connectors. So Azure functions, we can use that part. It depends on the requirement or the solutions which demands for the solution.
Thanks, Satya. So the next question is, let us know the top most important benefit of a composable structure from your view.
Okay. The first thing is like we don't have to kind of like worry much, because if I wanted to build a system, I don't want it to kind of like find the resources, right people, right technologies to have them boarded and kind of like build a solution. And moreover, that won't take it in a single day or like within shorter time or something. But in a composable architecture, already there are some proven composable components available. Let's say I wanted to kind of like integrate headless solutions with the front end stuff. We can go with XM Cloud, and I wanted to kind of like incorporate customer data platform. So I can incorporate CDP. Also, I have some data, legacy data available in Microsoft Dynamics, and which I wanted to integrate it through my solution. I don't have to write a kind of like solution, or like I don't want to build a solution to do the integration. iPaaS layer is available and it was sold by vendors. We can employ them and we can leverage their SaaS features. So this way, composable solution is kind of like a benefit and it is advantageous to us.
Perfect. Thank you. The next question is,
Mhm.
does composable architecture is cost effective over monolithic?
Good question. To be honest, okay. So in the monolith solution, while comparing monolith solution, composable architecture, it depends. One side, we need to list down what are all the composable components we will be using it. In the monolith side, we need to list down what are all the systems we already integrated it as part of that monolith. For example, like in a monolith, mostly like all the functionalities under the kind of like a single box. But in order to have kind of like these capabilities available in the composable part, right? It is like being a SaaS nature. It is like subscription based. Most of the SaaS features subscription basis. And another one is like in a monolith where you need to put capital cost as well as you need to keep a kind of like running cost. In composable, it is definitely kind of like lower than whatever we were seeing it in the monolith solution. And probably in terms of resources, learnings, and kind of like uh, the work culture on the teams who will be working with the transition part, right? That side, I may see some kind of like cost things because they required trainings, other stuffs and all.
Okay, perfect. Thank you. I'll take last two questions,
Mhm.
respecting the time. So the next question comes to you is, how would you prioritize and strategize API performance optimization in Sitecore composable architecture to ensure a seamless customer experience even under heavy load?
Okay. So the first thing is like, as I mentioned before, service mesh. Uh, in the service mesh, being in kind of like a solution where it is having a healing factor on the scaling side, traffic management side, we are outsourcing those struggles, challenges back to the kind of like service mesh side. And moreover, we need to identify which specific area is kind of like a vulnerable. Let's say during the festival season, right? Usually we will get more orders, and that time people may be searching more on the PLP pages. There are some services which is quite kind of like a demanding on that specific timings. If we can focus on that specific services area, we can kind of like increase the scale. We can scale them up. So this way, uh, we can make sure that surge load we can handle it. And moreover, we have a kind of like as I mentioned, one of the topic traceability and observability. Through the observability, we will be having the details of the utilization, throughput sum, uh, incoming requests, and how the system is performing against the load. Those information, we can review it. And the traceability side, we will get to know from where the conversions maximum started, from which point to which point, which service to which service, because few people, they already added some of the items into the cart. They'll be directly jumping into the checkout. But few people, they first go to the PLP pages, then their journey is kind of like a bit long way. So this way, we can identify kind of like challenging areas, and we can focus on those specific services alone to tackle the load and demanding kind of like I mean, to tackle the load.
Perfect. Thanks, Satya. And last but not least, the
Mhm.
question is, in case of any failure, how do you investigate the checkout flow?
All right. So it's a kind of like a traceability. Uh, this is a good question. I can give an example on the Kafka area as well. The moment, usually in our monolith solution or even in kind of like other areas, whenever we write any functions, we will be having adding the logging stuff. That is in terms of time span as well as in terms of process. When the multi-threading is happening, in terms of uh, threads, it will always logging in. But often when we go through the logs, it is very hard to identify the kind of like a sequences. Instead, if we employ Kafka for the log eventings based on the correlations. When there's a checkout, it will capture the information from start, beginning from the kind of like adding product into the cart, from cart to checkout to shipment, payment, then checkout. In this order, when we have this sequence in place, right, then it is easy for us to identify where the problem had occurred, or when the order is not placed, then it is easy for us to identify why order couldn't turn out on this conversion. It is like a more into kind of like a logging the information based on the user journey instead of independent single logs informations.
Thanks, Satya. So we have come to the end of the session. So the last piece